This is a production of Cornell University.
Yeah. Hello, everyone. I hope you're all having a great Wednesday. I'm Lucia Viñale. I'm organizing the hemp webinar this year. I'm a third-year Ph.D. candidate in the Larry Smart Lab at Cornell University, and I'm working with hemp father mildew. Today, our speaker is Tyler Gordon. He is a research geneticist with the USDA Agricultural Research Service Plant Genetics Resources Unit in Geneva, New York. He has worked with ARS since 2011 and joined the USDA ARS Hemp Project at its infancy in 2022. Tyler holds a master's degree in plant pathology from Oregon State University and a PhD in plant science from the University of Idaho. A quick reminder before we start, please use the chat for readings and other communications and submit your questions for Tyler using the Q&A button. The talk will last approximately 45 minutes and we'll follow it with a Q&A session. We'll wrap up and thank Tyler for his time and insights. A reminder, all webinars are recorded and uploaded to our School of Integrative Plant Science, SIPS, YouTube channel. And without further ado, Tyler, all yours.
All right, thanks very much for the introduction, Lou, and very glad to be here this afternoon from Geneva. And so I'm going to share some slides. So as Lou mentioned, this is a relatively new project to the USDA ARS, and we're based out of Geneva, New York. And this was our first trial. So this picture here was our first trial back in 2022. It's bringing back some good memories here. And these are all hemp plants. I had about 2 acres of very diverse hemp from all over the world, grown at these wide space plantings. And we're evaluating them for many different types of traits, and today I'll be focusing on the seed traits. And so this is a picture later in the season, just to kind of get an idea of some of the phenotypic diversity in this group. Later in the season, we're seeing these vivid colors, green, of course, and browns, but also purples and yellows. And then if you look at the seeds, there is quite a bit of diversity in seed size and color and variegation as well. So today, I really want to highlight this USDA hemp germplasm collection. That's a resource to the hemp community broadly, and then talk a little bit about the field trials that we've been conducting, and then really focus in today's talk, of course, is on seeds. So looking at seed shattering, seed yield, the size of the seeds, and then protein and fatty acid content. Then we'll summarize, and I'll try to leave about at least 10 minutes for questions at the end, and we'll be done at 2 o'clock. So again, this collection was started around end of 2021, and Zach Stansel, who probably many of you know, pictured here, has been doing a fabulous job obtaining germplasm from all over the world. And that germplasm's come in from agreements, exchanges, donations, and any ways that he can get this germplasm, he's happy to get it. And that's kind of the building block. Those materials provide the building blocks for hemp breeding, which includes breeding for these seed traits in hemp that I'm going to be talking about. Currently, there's about 700 accessions in the collection, and they're comprised of, accessions, we're referring to accessions like a cultivar could be an accession or a breeding line, or a variety. But then there's also these feral collections like US feral collections or land races from center of origin. And those come from North America, Europe, Asia. I think there's a few now from Africa as well. We're trying to develop this phenotyping handbook to standardize phenotyping. And that link is posted there. Feel free to check that out. And that's our effort to give a phenotyping evaluation resource to the hemp community. And then data that I'll be presenting here at the accession level is available on GRIN Global, and germplasm can also be requested through this GRIN Global website. Okay, so the field trials that we've been conducting and that I'm going to be talking about today are wide space field trials. So we're trying to let these plants have as much light, as much space, as much nutrients as we can to see how big they can get alone and unencumbered by other plants. So these are at about 7.5 foot spacing between rows and 3 foot spacing within a row. There's roughly 2,000 plants per acre, so it is very wide space. It's similar to folks growing high cannabinoid hemp. These were transplanted in a randomized complete block design. There's 2 environments that we evaluated seed traits for, and those are in New York here in Geneva, kind of upstate New York, and then Davis, California. I wanted to highlight Daniel Papp here, who's running the Davis trials. And then these were conducted in 2022 and 2023. We're looking at 136 accessions, and there are, as many traits as we could evaluate and think of to evaluate, including architecture traits like plant height and plant width, cannabinoid profiles, importantly, total THC levels, fiber quality, and then seeds, which is what we'll chat about today. And just to kind of give a background, I'll be talking a little bit about the descriptive statistics, so just the minimum, median, and maximum levels of the response that we found for some of these traits, but also be giving estimates using this mixed model where accession or type of accession was used as a fixed effect, and then year, location, and block are random effects. And then we're using Tukey's HSD for mean separation. And so these are kind of the 2 main groups that we're interested in. One is at the accession level, where there's 136 accessions, and the other kind of grouping that we're using to look for differences is type of accession, where we use passport data and information given to us by accession donors to designate accessions as Asian origin, European origin. These are mostly US ferals or chemical or high cannabinoid types. And then there's kind of the catch-all uncertain if we didn't know. Let's see. So just kind of jumping right into this trait that looks like it's going to be very important for seed producers, seed and grain producers of hemp, is seed shattering. So right off the bat, when we started this work, people mentioned that seed shattering is really going to be a trait that's important. So we kind of looked around and found these breathable mesh bags. So these have a 336 micron size. And this is from the company website, this picture down in the lower left, where these are used to exclude insects for insect pollinated crops like sunflower. But what we're using them for is covering the inflorescence or zip tying that, and that lets water and air and pollen permeate this membrane, but seeds are retained in this fabric. And this is if anyone's interested in doing this kind of assay themselves, the product is this PQ218 from Midco Global. And so we have these seed shattering bags. We place them on an inflorescence 35 days after flowering. We're targeting 3 plants per plot, and then cutting the bag with the inflorescence on it off once the plant dies. And so, we've been kind of using the fan leaves turning brown and falling off the plant as that determining factor, that threshold when the plant is dying. And then we're drying these bags and opening them up and measuring if you can see this picture here of the screen that we're running. So we're cleaning the seeds, and then we're measuring the seeds that are loose in this bag and the seeds that are retained on the stem in the bag. And so the measurement we're looking at is the loose seeds in grams over the total amount of seeds collected in this seed shattering bag. And then, so coming back to this type of accession, you can kind of see the estimates here for percent shattering. So this is incredible. So 50 in the feral accessions, across all feral accessions, our estimate using the mixed model is 57. So over 50% of the seeds are shattering. That's amazing to me. Just comparing that number to other grain crops like wheat or oats, where that number would be, almost 0. And so you can kind of see here, this is our box plot on the left, where we have the type of accession along the x-axis and the shattering percent on the y-axis. And here's 0% shattering to 100% shattering. You can see across types, we're getting individuals that do have 0 or close to 100% shattering. And then here the median range is this dark black line. And one other thing to point out here is the connecting letter here on the table on the right. So these letters that are the same, so for feral and Asian origin materials, the connecting letter is A and AB, so these are not statistically different, whereas the feral types and the chemical types do have a different connecting letter, so they are different statistically at the 0.05 significance threshold. So that's kind of how to read these. We'll be looking at a lot of these charts going forward. And then seed shattering across accessions. So this, we're trying to simplify this information, but I think these box plots are really, really informative. You can see some accessions have, almost no shattering, all the way up to, so here's shattering on the x-axis, so 0 to, 0 to 100% shattering. And then there's different types that are color coded. So the accessions are here on the y-axis, and then the type of accession is color coded. So we have Asian origin accessions are going to be in green, and then chemical origin are going to be orange, European purple, feral this pink color, and then uncertain is this tannish green color. So that's kind of how these charts work. And then we're zooming in on the accessions with the lowest amount of shattering, which is what folks growing hemp for grain or seed production are probably most keen to learn about. And we blew them up here in the table on the right. And so you can see that the type of accession, the accession name, this name you can look up on Grin Global, this G number. And then the name is a shortened name from the accession number. And so there's 10 of these that we're focusing on here with their shattering estimate. And you can see they range from 6.8 is the lowest value that we're estimating with Yunma, it's Chinese origin. And then the highest value in this, in this subset here is going to be 12% with this accession with uncertain type. But many, what's kind of fascinating, we'll see this pattern as we move through other charts, but many of these accessions with the lowest seed shattering are chemical or high cannabinoid type accessions. So kind of moving on to seed yield. So here we're actually, this was a big project, of course, but we're trying to get the seed yield from one individual plant. So you can see, I mean, these plants oftentimes are as big as we are. And so we're taking these plants, we're cutting them up, we're putting them into a bag, we're processing them with a belt thresher right here, shown on the in the image on the left side. And then we weigh the clean seeds shown right here. And you can see right away just a size difference between two of the accessions. And so plant seed yield across accession types. So again, accession type along the x-axis and seed yield now in grams along the y-axis. And just some trends that stand out right away. Again, it looks like chemical types are coming out a little higher with the median seed yield, and these ferals are coming out lower as we probably would have expected with feral material. And here's the estimates and connecting letters for the different types of accessions that we're looking at. And then kind of in a similar vein, we'll look at the plant seed yield across the different accessions. Again, now we have grams of seed on the X, so 0 grams, and then here's 15 grams, and then these are box plots for each accession. And then the most folks are probably most interested in the accessions that yield the most per plant, and those are listed here with their estimates. And so in this subset, we're looking at a range between 8.6 grams and 11.8 grams for golden redwood. And interesting here as well, like most of these accessions with the highest yield per plant are chemical origin, which was we didn't really know what to expect with this trait, but that's kind of a neat finding to see. And so now we have all these seeds, and we wanted to measure the size of the seeds. So we have our seed analyzer, Justin Kaufman, who just did a phenomenal job using the actual seed analyzer. We've got this seed analyzer from comes out of Germany, and it can measure the actual size and area and number of seeds. It can do this very rapidly. It gives us about 10 different data points or different traits for the seeds, but we'll just be talking about seed width, the 1,000 seed weight, and the test weight, which is going to be reported as kilograms per hectoliter, which is 100 liters. So the amount of kilograms in 100 liters. However, we're deriving that from a very small volume because we don't have very many seeds in a lot of these cases. So it's 8.5 mil volume. We're converting that to kilograms per hectoliter. So a seed width, let's just quickly look at that. Again, type of accession along the X, and seed width in millimeters along the Y. And then the estimates here are in this table between 2.7 and 3.4. And we are seeing a significant breakout between the different types of accessions, again with ferrules kind of coming in lower with seed width. And seed width across accession, so it's the same trait, but now we're looking at the individual accession level on the Y here, and the X is seed width in millimeters, 2.5 millimeters here, and 4 millimeters here. And so we're looking at a range between 3.4 and a little over 4 for some of these fairly well-known Chinese accessions, Jinma and Yunma. And then 1,000 seed weight. So now we're TSW 1,000 seed weight in grams, going from 0 grams to 30 grams across type. And it looks like there is these Asian origin accessions do have significantly higher test weights compared to the other types of accession. And then let's look at this again. Okay, Yunma. Okay, very interesting. Probably what we would have expected, where seed width and 1,000 seed. So the wider the seed is probably going to weigh more, and that looks like it's the case here as well. So 1,000 seed weight along the X from 10 here to 30 grams here, and box plots for all these different accessions, and the table of the different accessions that are in this kind of upper, the 10 accessions with the highest 1,000 seed weight are listed there. And then test weight. So test weight, again, is going to be a weight per volume. In this case, it's recorded as kilograms per hectoliter. And we're ranging here 45 to, we got some, a few outliers exceeding 65. And then a little bit of breakout, looks like as we may expect here as well. As the seeds get smaller, they're going to be more space efficient. So the ferrules actually come out on top here for test weight. And then across successions, so here we've got test weight in kilograms per hectoliter from 40 to 70 on the box plot, and then the table showing which individual accessions have the highest test weight and the different the types of accessions represented in this subset. All right, and so now moving on to seed composition. So we've gotten seed shattering, we've gotten seed yield, we looked at a couple of the seed size traits using that seed analyzer. And so we have these seeds. We've got this great collaboration with Dr. Roque Evangelista at the National Center for Agricultural Utilization Research in Peoria, Illinois. And here's Roque out sampling some seeds from some hemp seeds. And so we sent him 5-gram samples of these seeds, and he analyzed them for their moisture content, total protein, and oil content. And the data that I'll be showing today is going to be reported as it. So it's the total seed percentage. So if you see a number like 10%, that is 10% of the seed was water. And so within the oil category here, there were 13 fatty acids, and this particular fatty acid that's shown is linoleic acid, which happened to be the most prevalent fatty acid in the hemp seeds. And so these are really long chain carbon molecules with a hydroxyl group on one end, and then they can either be saturated where they don't have any double bonds, mono unsaturated where they have a single double bond in this chain, or polyunsaturated fatty acids where they have more than one double bond, like this linoleic acid has 2 double bonds here. And so imagine this is a seed. So here's a hemp seed. And just across everything that we sent Roque, let me go back here. Everything we sent Roque, this is kind of like the average value from those seeds. So here's the moisture content, which came in a little under 10%. Seed oil was here, which, and then, so we've got a pie chart on the left, and on the right are these box plots to kind of show the variability across the 4 main categories that were the 4 main categories of component that was in the seed. So seed protein here, about median's a little over 20%, seed oil a little over 30%, moisture below 10%, and then other, which could be likely carbohydrates and ash fibers, things like that, are going to be way up here over 40%. However, we did not look for carbohydrates or ash content. Those were not things that were analyzed. Okay, and so let's do a little deeper dive into the fatty acid composition itself. So if this was 100% of the oil, what slice of each, what component is represented in each one of these slices? And so you can see that types. So the polyunsaturated fatty acids have this kind of a little bit of a texturing here. And so they're represented by alpha linoleic, gamma linoleic here. And then the major component of the oil is linoleic acid. And so you can kind of see the breakout of the different types of fatty acids and then the specific fatty acids themselves. And again, linoleic, the percentage of the oil is about, over 55%, and percent of seed, 16%. And then within the monounsaturated fatty acids, oleic acid was the highest component, with 3.5% of the seed. And then within the saturated fatty acids, we have palmitic with 2% of the seed was palmitic acid. And so I'll kind of leave this up for another few seconds. So it's a lot going on here. And these videos will be recorded, so you can come back to this data later. Okay, so just kind of coming back to our typical box plots here, where we're looking at type of accession along the X and percent seed oil on the Y, ranging between 24-36%. And what's kind of interesting as we get into the oil, and as we'll see with some of the other components that we look at, there are numerical differences between types and within accession for these traits, but there's typically, we're not seeing very much statistical significance between them. So seed oil across accession. So just as, again, just kind of highlighting the 10 accessions with highest seed oil composition, ranging from 32 to 34% here. And these are kind of, it's not dominated by the chemical types anymore. There's some feral material in here, along with a chemical and Asian origin. And then seed protein is, super interesting to those folks. I know we had a really good talk last week from a baker that was interested in hemp seed protein. And so here's some data to kind of provide some guidance for those wanting to grow hemp for protein. And again, it doesn't look like there's a terrible amount of difference between the different accessions, or between the different accession types. And we're kind of seeing that here within accessions as well, where seed protein content ranges between 18 and 24%. And here are, our top protein producers. Of course, maybe some folks might be interested in low producers as well. So there's that information. And then just kind of looking at at a correlation analysis between the traits that we've talked about so far. So we have shattering fraction, yield on plant, 1,000 seed weight, test weight, seed width, seed oil, seed protein. And then this trait is 100 seed weight that's taken when accessions are first donated to the NPGS, to our germ bank. our germplasm bank. And so that's kind of interesting. So I'll just kind of focus on this trait first. So this 100 seed weight is presumably the seed when it's grown. So if we get some, say, gin moss seed in from a producer growing gin moss seed, we're presuming that that was grown. You know, it's probably more pure than the material that we're growing out in the field. And so let's compare that 100 seed weight to the 1,000 seed weight that we're getting from these trials. And there is a fairly high positive correlation between the two. And then some other kind of interesting correlate. So how these correlation matrices work is you'd compare, say, 1,000 seed weight here to test weight here, and you can look at it here in ellipses or in these squares up in the upper right hand triangle, or in ellipses in the lower left hand triangle. And so let's see, so this is kind of a neat trait to focus on here. This is yield on the plant. Very high positive correlation with 1,000 seed weight, another high correlation with seed width. And seed, so this is a weak, relatively weak correlation here with seed protein. And then shatter fraction, as you might expect, as you get more and more shattering on a plant, you're going to have presumably much less, you will have less yield because those plants shattered out on the ground. So there is a strong negative correlation between shattering, higher levels of shattering, and higher yields on the plant. And then here's another one. We'll just focus on this one here. 1,000 seed width, or 1,000 seed weight, sorry, and seed width with this very strong positive correlation here, 0.95. And that's kind of, what you'd likely expect. And what we saw earlier with the accessions that had the highest seed width also had the highest 1,000 seed weight. And then another thing that's been reported in many other crops is this negative correlation here between seed oil content and seed protein content. So as the oil tends to go up, seed protein levels decrease. All right. So just to kind of summarize, let's see, how are we doing? Yeah, okay. So just gonna try to wrap this up here in the next 5 minutes or so. So to summarize, these were the traits that I was primarily talking about. So shattering, plant seed yields, seed width, 1,000 seed weights, test weights, seed oil percentage, and protein percentage, seed protein percentage. And so just based on our estimates, here are the mean values, the maximum, and the minimum. And so you can kind of look through that chart to get a summary of these different traits in the accessions that we're looking at. Let's see if there's any specific things to point out. Just the range, is there's a much greater range in some of these traits, like test weight or 1,000 seed weight than there are in some of the other traits. All right, and so this is a comparison with the hemp seed. So this is the data that we're just generating now, just coming from that table we just looked at, compared to some estimates from soybean and canola seeds from various locations and various reports. So they're, wide ranges, but hemp seeds, yeah, I mean, they are generally kind of falling close to some of these metrics, especially canola, especially with the canola seeds. All right. And so we are kind of continuing this type of work. We have this in 2024, we wrapped up 2 years of these small plot trials. So they're direct. So the data that I just shared was from these wide-spaced planting trials, kind of like high cannabinoid style. Not likely how hemp grain producers would plant their crop. So in 2023 and 2024, we planted with a drill, so direct seeded these small plots at high density, so 2.4 million and 1.24 million seeds per hectare in these small plots, and we're getting seed, the same kind of seed composition and trait analyses are being conducted on seeds pulled from these trials, and that should, of course, those estimates are going to be a lot more in line with what a farmer would get when they're growing at the acre, 100-acre scale. And then we'll also be able to compare those values with the wide space plantings that we have. So just to conclude here, this data, most of it's already available at the accession level at this website here. And so I'd encourage people that are interested in any hemp traits. There's over 100 different traits already reported on this website, and that's kind of our clearinghouse for data. It's a invaluable resource if you're breeding for hemp or growing hemp. I think that's going to be a great go-to tool for you. And we covered a whole bunch of different traits, including shattering, yield, size, protein, and fatty acid profiles in hemp. Today saw lots of data, and yeah, just really hope it's useful to the community. And I wanted to thank the team here, the USDA ARS team. There's a lot of long days out in the field, a lot of long days processing samples, and that without this help and concerted effort, we don't generate this data. So just kind of specifically Ava, Justin, Tony, Gabi, Tori, Kevin, and Kevin. So thank you guys. This was part of another trial that we started in 2024, where we're sequencing many of the hemp accessions, and so hoping to make that sequence data available to this community as well. Feel free to ask questions in the chat now, or you can reach out to me or Zach. Our emails are listed here.
Thank you, Tyler. That was an amazing talk. I think we have like 21 questions for you already. So,
okay, awesome.
yeah, go ahead.
Do you want? Oh, okay. So the first question is so I'll read out the name of the person and then I'll read out the question. So the first question comes from Farley Gordon. Is there an address to request cannabis seeds? And yeah, so please check out the GRIN website. that's an amazing resource to look at this data. And if you're a researcher or breeder, you can request germplasm through there as well. And the next question is from Sheridan Banta. How far are each, let me blow this up a little bit. How far are each plant from each in in the trial, I presume? Yeah, so we have, so for this trial, it was 7.5 feet between rows and 3 feet between plants. Okay, so the next question is from Farley Gordon. Has funding changed with the new administration? And I presume this is talking about ARS funding. And we don't exactly know yet. So, and then another question from Farley. I have a patent pending hemp construction building block, but can't get it going due to funding. Help. Okay, yeah, please reach out if we can be of assistance, Farley. Let's see, this one. Okay, here's a question from XK Camo. What is the pollen source for the seed production in these trials? Yes, okay, so that's a great question. These were all open pollinated, so it could have, the pollen could have come from any male in this field or in the vicinity. And so, yeah, that's a really good clarification there. Here's a question from, let's see here, from Miriam. If I'm performing a greenhouse experiment on dual hemp, at what time point should I put the bags over my plant to catch the seeds? Okay, yeah, so we have been putting the shattering bags on the seeds at 35 days after flowering. And that seems to work fairly well to catch the seeds. That's what we're using. It might not hurt to put them on a little bit sooner than that. But it's the reason that we're waiting that long is we want, really good pollen flow. And pollination, and we, we want to disturb the plants as little as possible before we add those shattering bags. Okay, here's a question from Sheridan Banta. With industrial hemp, do you want high or low seed shattering? And I mean, if you're a grain producer, you would want no seed shatter, so very, very low seed shattering, because the more seed that shatters, the less yield you'll get. And then a follow-up, based on the list, what would be the best performing, highest yield for industrial hemp? Let's see. So there were some very good options. Let's see. So just I should have this memorized, but the so if we're just talking about yield, there were a couple really good ones. So golden redwood, we had one called Chinese hemp fiber, ACDC, hempress. Those all performed quite well for yield. However, as an industrial hemp producer, you may be interested in, say, protein content or oil. So it kind of depends on your final use for the product. Okay, here's a question from XK Camo. Does your team believe chemical types yielded greater seed weight due to breeding for higher cannabinoid content? being that the nutrients used by the plants would be diverted from seed production into cannabinoid production. I don't really know. We were not necessarily expecting the chemical types to perform very well. This is this is very much like we are just looking at seeds here in this presentation, and I wouldn't have necessarily guessed that they would perform as well as they did. So I don't really know why. I would maybe guess that high cannabinoid breeders are also interested in low shattering for their seed production systems as well. Just a guess there. Jillian McGee, do you have a sense if the lower feral yields are due to smaller seed size or yes, okay, this is a great question. Yeah, so feral seed yields do look low because there's tons of seed shattering. You saw like the mean across the different feral accessions was over 50%. So that's that is your seed going away. And then yes, they also had smaller seed size, and that is not uncommon to see in feral or wild type accessions in other crops. Caleb Chin, curious if you'll consider splitting Asian into Central Asian, South Asian. Yeah, that is a good point. That might be something that we look at in the future. Should we split these out more? We're trying to do both here in the presentation and show like accession level and then kind of lump together as broadly as we could. But yeah, that could make sense to split into additional types of accession. This is a question from Luis Monserrate. Do you observe consistency in seed size for accessions grown both in New York and California? Okay, thank you for the question, Luis. Yeah, I did not show the statistics table for these, but for seed size, we're not seeing a significant difference between New York and California. And we can chat about, I know Luis, you're just right down the way here, so we can chat about some of the other traits if you like. But just kind of to the group, we're not seeing much of a location difference across the different traits. Okay, here's a question from Sheridan Banta. How does the protein and oil content compare to soybeans used for chicken feed? Yeah, okay, great question. And I tried to address it in the table. So protein content is lower in the hemp seeds that we were looking at, and oil content was a little bit higher. Chuck Schmidt, what is a chemical type? Okay, yeah, so the types. Again, when we are classifying these as type, we're basing that on what people tell us when they donate the seeds. So if people said they grew these for CBD, we would list them as high cannabinoid or chemical type. Here's another question from Luis. What is your best explanation for an overall very low seed yield per plant? Yeah, I mean, it looks like two of the biggest drivers are seed size and shattering. But as in other crops, there could be other, there's probably other explanations and variability there, like how many seeds are produced per, per centimeter of inflorescence. but I'd say two big ones are shattering and size. Let's see. So there's some questions here about my recommendations. I mean, I put the data up there that will be available for you to look at. I'm not certain that I could recommend a specific variety. There are many varieties to choose from, and here's data. Take a look at that data and see what might work best for your operation. Yeah, okay, here's a question about monoecious varieties from XK Kamau. Do we have monoecious? Yes, we do have. Yep, there's quite a number of monoecious varieties or accessions here. Assessing facilities. Here's a question from Sheridan Banta. Is there a centralized resource that lists industrial hemp processing facility locations around the US? That is a good question. And I don't know about that resource. Maybe Lou or someone else on this webinar knows the answer to that, but I'm not aware of it. One person that would be, feel free, send me an email and I'll connect you with Daniela Vergara, who's the Cornell hemp extension specialist. And I would guess she might know that information. And then the last question is from Nico Videla. It's just asking about the oil yield comparisons between soybeans, canola, and hemp, and how are they compared. If you check that chart out, it has the different measurements used for each trait. Here's a question, parameter. Okay, it's a question about the correlation between viscosity of seed oil, and I don't know the answer to that. For any of these questions, do feel free to reach out to me via email, and I can try to hunt some of these answers down. And that looks like one last question. How many acres of hemp does USDA expect to be planted in 2025? And I presume that's all acres in the US, and I don't know the answer to that either.
Awesome. Thank you, Tyler. It was a fantastic talk, and we've been really lucky to have been able to go to those fields here in Geneva and see all those diverse plants that you had over there. We're wrapping up for today. We've recorded the webinar and we're going to upload it to our SIPS YouTube channel. I will copy again in the chat the link if you want to check out Tyler's webinar in the coming days, or if you want to go back and watch the previous ones. Have a wonderful rest of the day and see you in 2 weeks. Thank you, Tyler.
This has been a production of Cornell University, on the web at cornell.edu.